Every growing business eventually compiles a dusty manual of standard operating procedures. You spend weeks documenting every single operational step, from how to process a client refund to how to format a weekly media report, hoping it will finally free you from the technician's chair. But the moment you hand this PDF or Notion document to a human team member, or try to automate it using basic AI tools, the friction begins. Human operators misinterpret the nuances, skip minor steps, or introduce manual errors. Meanwhile, traditional language models, when prompted on the fly, hallucinate instructions, ignore your specific brand guardrails, or spit out generic corporate fluff that requires heavy editing. A static SOP is fundamentally passive. It is a piece of text waiting to be interpreted. To achieve true operational autonomy, we must transition from writing passive documents to engineering active deterministic skill files. A skill file is not a casual prompt typed into a chat interface. It is a highly structured, self-contained operational module that fuses rigid business logic, granular conditional execution rules, and persistent context directly into the cognitive core of an advanced model like Claude. Today we are diving into the exact click-by-click technical blueprint required to build your own skill files, specifically engineered for autonomous SOP automation. We are moving past the theoretical hype and opening up the hood to show you exactly how to format, structure, and deploy an intelligent digital operator that executes your complex workflows with zero latency and absolute precision. Before you write a single line of your skill file, you must abandon the standard chat box mindset. When you prompt an AI inside a consumer interface, the model operates with a blank slate every single session. It has no memory of your business parameters, your past interactions, or your operational boundaries. A .skill file solves this vulnerability by establishing a strict, multi-layered document architecture that forces the model to evaluate incoming data through a highly disciplined operational filter. Your very first step is to create a plain text document, saved explicitly with a skill extension that houses this architecture. We will break down the exact contents of this file, starting with the identity header. This section acts as an unyielding digital bodyguard for your business data. It explicitly forbids the model from fabricating information, making unauthorized commitments, or hallucinating operational steps. You hard-code your absolute corporate boundaries directly into this header. If your SOP dictates that client deliverables must never be sent via email, but rather uploaded to a secure client portal, the system encodes this as an unbreakable rule. By locking these constraints into the persistent system prompt, you ensure that no matter how complex the edge case is, the digital operator never compromises your operational standards. With your identity header firmly established, we move to the operational engine of the skill file, the deterministic logic core. This is where you translate a traditional multi-page human SOP into a machine-readable step-by-step decision tree. We will walk through the exact process of constructing this core using a high-value operational example, the automated generation and auditing of a client onboarding report. Step 1. Ingestion and parameter mapping. Open your preferred code editor or structured text workspace and create a new file named client_onboarding_audit.skill. At the very top, define the system role using clear markdown headers or XML tags to separate the logic. Define the operator persona. You are an autonomous operations director for a digital agency, operating with zero tolerance for administrative error or output hallucination. Establish the core objective. Your sole task is to ingest raw client intake data, verify it against the master service agreement, and construct an audited onboarding report. Step 2. Codifying the step-by-step execution rules. Next, you write out the explicit workflow steps that a human would typically perform by hand. Instead of writing casual paragraphs, you use rigorous conditional logic arrays. Rule A. Data validation. Cross-reference the incoming client data against the active CRM register. If any required fields, such as contact emails or project scopes, are missing or invalid, immediately halt the workflow and output a structured error flag. Rule B. deliverable assembly. If validation passes, extract the specific service tier selected by the client. Match this tier directly against your hard-coded product menu array. Rule C, tone and voice guardrails. Process all generated prose through a linguistic conversion filter. Forbid the model from using sterile corporate cliches like, "I am delighted to assist you," or "It is crucial to emphasize." Force it to adopt a clean, punchy, conversational tone that matches your personal brand voice. Step 3. Structuring the output schema. The final section of your skill file dictates exactly how the processed data must be formatted before it exits the cognitive model. This ensures that the output is instantly readable by your downstream automation apps such as Google Flow or Zapier without requiring any manual retyping or formatting adjustments. Instruct the model to output its final response within strict, predefined JSON or Markdown blocks. For example, specify that the onboarding report must include specific keys for client_ID, onboarding_status, assigned_deliverables, and next_billing_date. By hard-coding this structural discipline, you create a perfectly deterministic pipeline where data flows seamlessly from raw input to beautifully formatted output with absolute zero human intervention. Simply creating a skill file on your local machine does not make it an autonomous operational engine. To bring this architecture to life, you must connect the file directly to your cloud infrastructure so that it executes dynamically whenever an operational trigger occurs in your business ecosystem. The technical integration relies on linking an advanced models API to your centralized cloud file storage and automated webhook platforms. You upload your newly created skill files into a secure, dedicated directory within your Google Drive or cloud repository. Next, you configure an automated webhook, powered by Google Flow, to monitor that specific skill directory. When an event occurs, such as a client submitting a new intake questionnaire, the workflow fires instantly. It grabs the inbound client data, calls the Claude API, passes the relevant .skill file as the system instruction, and retrieves the polished deliverable. The automation then deposits that audited report directly into the client's dedicated shared folder, updates your internal project management dashboard, and archives the metadata. Your agency's operational workflow moves at an elite, computational speed while your attention remains completely undisturbed. By substituting fragile human coordination with a streamlined network of deterministic .skill files, you permanently decouple your revenue from your time. Your operational overhead drops to near zero, your execution speed accelerates to instantaneous levels, and your business gains the capacity to scale effortlessly without requiring you to sacrifice your personal focus. You transition from a stressed operator constantly putting out daily administrative fires to a true system architect tracking computational metrics from a position of absolute professional autonomy. The fundamental flaw with traditional business operations is that static text documents cannot enforce their own instructions. Continuing to write long, passive PDFs for your workflows simply opens the door for execution latency, human oversight, and messy AI hallucinations. Your tactical challenge for the next 24 hours is to take just one multi-step instruction from your company handbook and strip away all the conversational filler. Rewrite those exact steps as a strict, logical sequence of conditional instructions, defining exactly what the inputs are and what the output schema must look like. That document is your very first functional skill code block. If you want to bypass the trial and error and get immediate access to the exact skill file templates and input/output parameters featured in this video, grab the system files down in the description below. Make sure to click that subscribe button because in our upcoming tutorial, we are exploring how to embed advanced prompt injection guardrails directly into your code skills to keep your internal business data completely locked down. See you in the next one.